So today we will discuss about how to find the stability using Routh-Hurwitz stability criterion. So a system is given with the following representation. So you can see system is given in block diagram representation with C of S is the output and R of S is the input of the system, where open loop transfer function is given by 1000 divided by S plus 2 into S plus 3 into S plus 5. So here our open loop transfer function is G is equal to 1000 divided by S plus 2 into S plus 3 into S plus 5, and feedback path transfer function. So you can see in the feedback loop there is no specific transfer function, hence it is a unity feedback transfer function. So H of S is equal to 1 and the system is having negative feedback. So in order to analyze the stability using Routh-Hurwitz criterion, first we have to find out the closed loop or overall transfer function of the given system. So first we have to find the closed loop transfer function of the system, that is C of S by R of S is equal to, you have to apply the formula G divided by 1 plus GH. In order to find the closed loop transfer function, you have to apply the formula G divided by 1 plus GH. So we can find the closed loop transfer function is equal to 1000 divided by S cube plus 10S square plus 31S plus 1030. So we have got the closed loop transfer function or overall transfer function. Now we have to write the characteristic equation of the system. So what is the characteristic equation of the system? The characteristic equation of the system is from the closed loop transfer function or overall transfer function, take the denominator and equate it to 0. So here we have the closed loop transfer function and its denominator is S cube plus 10S square plus 31S plus 1030, that is equal to 0. So this is the characteristics equation of the given system represented in block diagram representation. So when we got the characteristic equation of the system, we can assess the stability using Routh-Hurwitz stability criterion. So in order to assess the stability using Routh-Hurwitz criterion, first we have to form the truth table. So once again I will write the characteristic equation, that is S cube plus 10S square plus 31S plus 1030 equal to 0. Now draw or form the Routh table. So in order to form the Routh table, first we have to write the power of S from starting from highest power in the descending order, that is we have to form the Routh table rows, that is S cube corresponding to S cube will be your first row, second row will be corresponding to S square. Now you have to write it starting from the highest power of S in the descending order. Now S raised to 1 and S raised to 0. Now in order to write or in order to form the first two rows, here it is starting from S cube, so you have to check the coefficient of S cube here. So you can see that the coefficient of S cube is 1 and we can put a 1 here. Now in order to write the second element, take the alternative element. So here s cube is your first element, so the alternative term will be 31s. So corresponding to s, the coefficient is 31, so we can write the next element in the first row as 31. Now corresponding to s square, what is the coefficient here? That is 10. So we can write 10 here. And after that, again you have to take the alternative element starting from s square. So 10s square, the other alternative element is 1030. So we can write 1030 as the next element in the next or second row. Now we only have 4 coefficients, that 4 coefficients that we have represented here in the Routh table. Now we have to find the coefficient of S1, that we can find using the equation 10 into 31 minus 1 into 1030 divided by this 10. Okay, 10 into 31 minus 1 into 1030 divided by this 10. So by applying this equation, we can find the coefficient here, that will be minus 72. When you multiply 10 into 31 minus 1 into 1030 divided by 10. Now what is the next element? Here you can see only there are no elements, only 4 coefficients are there. So the next element here will be 0, because here there are no elements are there because of 4 coefficients. So next element will be 0 here. You can directly write a 0 if there are no elements here. So in this table we can see that there are only 2 columns are present, 1 and 31, also 10 and 1030. So we can write a 0 here. Now in order to find the value of coefficient of s raised to 0, that is again 72 into 1030 minus 0 into 10 divided by minus 72. So minus 72 into 1030 minus 0 into 10 divided by minus 72, it will be 1030 itself. Now you consider the first column, this first column of the Routh array. So when we consider the first column of the Routh array, we can see that there are 2 sign changes. There are 2 sign changes in the first column of Routh array. What are they? They are plus 10 to minus 72 and minus 72 to minus 72 to 1030. So since there are 2 sign changes, that means it means that 2 poles are lying in the RHS of S plane. 2 poles are lying in the RHS of S plane and the system is unstable. Since 2 poles are lying in the RHS of S plane, the system is unstable. So in order to check the stability using Routh-Hurwitz criteria, first we have to form the Routh table. After that we have to assess the stability by checking the first column of Routh array. So here, since there are 2 sign changes in the first column, 2 poles are lying in the right hand side or right half of S plane, hence the system is unstable. If any one of poles are lying in the RHS, if any one pole are lying in RHS, that means the system is unstable. So here from Routh-Hurwitz stability criterion we can easily assess the stability, but the drawback is that you will get how many number of poles in the RHS and LHS. Only you will get the how many number of poles are lying in the RHS of S plane. We will not get any information about the location of poles. That is the drawback of Routh-Hurwitz criterion. So here we got that two poles are lying in RHS and hence the system is unstable. Thank you.